So today we're going to be covering 4.1 and 4.2, dealing with the rectangular coordinate system and graphing. So a lot of this, again, a fair amount of this should be review. We covered this in our previous class, Math 70, but again, we're going to go through this just to make sure everyone is aware of the requirements of what I'm looking for, how to plot and create graphs and things of that nature. And again, we're condensing this down into a single, lecture, as it were, because I think both of these flow very well together in that regard. So we'll be covering all of these in one recording here. So our basics with graphing is a generality. So if you're asked to graph or do anything like that, here is what we're going to need to do. When you are going through and setting these things up on any of the tests, on any of the homework, if you are submitting work to me, these are the requirements that I'm looking for. If you are missing any one of these in the graph that you are setting up, that means you are going to be losing points on the graph. So these are absolute musts, like no exceptions. These have to have all of them. So setting up and plotting points. So the requirements that we have. Set up your axes. So you have a vertical line, you're going to have a horizontal line, you're going to have them cross somewhere. Label your axes. They might have one's the X, one's a Y, anything like that. So make sure you have one labeled as X, one labeled as Y, one could be T, one could be H. It does not matter. It might be different in the context of the problem, but make sure each of your axes is labeled accordingly. You can go on top of this, define the positive and negative directions of the axes. So which way do we get positive numbers? Which way do we get negative numbers? We're essentially creating a vertical and a horizontal number line. I have seen many a times people will put both directions of a number line to be positive, and then wrong answers come out of that. So define the positive and negative directions. And then also scale them, meaning your axes, accordingly. Are you going by ones? Are you counting by fives? Are you counting by tens? Whatever it may be. Make sure you have that clearly well defined for yourself and for me or whoever is grading that. When you are creating graphs in this class or any of your other classes, these are the requirements your instructors should be looking for. If you do not have any of these written in, then you're going to be losing points. So make sure that you have your axes labeled and everything is as neat as possible. Organization is absolutely crucial with graphing. And if you are not neat and organized with that, a lot of this falls apart. And we'll go through an example of this here in a minute to show you guys what I'm looking for, my bare minimum requirements for this. So when we are starting to plot points, and we'll be going through that here shortly, we're going to start at the origin, which is right at 0, 0, where the two lines, the two axes are going to intersect each other, and move the corresponding number of places based on the ordered pair's numbers and signs. So we'll have some examples here that we're going to go through in a second. But remember, again, we need to make sure we have these requirements when we're setting up our graph. We need all of this done before we do any kind of graphing or plotting of points whatsoever. If you are not having any of this written down on your scratch work for the test, for instance, I will be taking off points. Even if on the assignment itself it says, oh, you have everything plotted correctly, if you do not have this written down correctly on your paper, I will be taking off points. I will go in and I will manually override the grade in WAMAP. I'll be taking off points if any of this is missing. So let's go through some examples of plotting some points here. So these are the ones that we're going to go through. I'm going to jump us over to our whiteboard. We're going to go through how to plot these ordered pairs on a set of axes. Let's jump on over to our whiteboard. Right over here. Okay, so we're going to plot 4 points that have been given to us. So our bare minimum requirements, and then how do we plot these things from here? So our example is plotting points. Okay, oops. There we go. Okay, so I'm going to list each of these points we have out. I'm just going to label them A, B, C, and D. And I'll keep their values with them as well. So point A, we're going to let be 2, 4. Point B is -1, 2. Point C is -3, -5. And point D is 5, 0. Okay. There we go. Okay, so we have 4 points that we need to plot. But again, we need to set up our set of axes. We need to make sure every last aspect of those requirements is set up and fulfilled for ourselves. So I'm going to, with this, because it's a nice part, it's got a grid attached to it. I'm going to start with making for myself, here's my origin. I'll set up my horizontal axes. Horizontal one there. Vertical one there. So I have my horizontal, vertical, good to go. Next thing we need to do, label your axes with X, Y, T, H, etc. So I have my horizontal axis is going to be X, vertical axis is going to be Y. So something like this is acceptable. If you want to put the labeling on both ends, you're welcome to do that. But as long as you have this, at the very least, you're fine. We then need to define the positive and the negative directions on this set of axes. You can accomplish this, and again, I'm showing you guys the bare minimum requirements of what you have. You can put a little plus, a little minus, or in front of the positive directions. Then you can put a little minus on the negative side. And again, we need to emphasize the positive and negative directions because we can and will have positive and negative numbers showing up. If we do not have that labeled for ourselves or very clearly labeled, then errors occur, and errors can occur very frequently when we do that. And then we need to scale the axes accordingly. So am I going to scale each of these little tick marks by 1s, by 2s, by 3s, 5s, 10s? What are we going to go with that? Well, I'm looking at the points that we have. We don't have any particularly big numbers that are showing up, which is fine. So what I'm going to do is I'm going to scale each of these tick marks to go by 1s. Now you have the choice, it's your call, if you would like to label each of these as 1, 2, 3, 4, etc. Or you can count by 1s and then just give me, here's 5. So I can count out 1, 2, 3, 4, 5. Okay, at 5, tick marks to the right. We're at +5. Great. I know what you're going by. We go 1, 2, 3, 4, 5 in the negative direction, then we have a -5 labeled in there. I'm fine with that as well. Same thing along the vertical axis. If I'm counting by 1s, I can just list, okay, there's a 5 up there, and there's a -5 down there. Now the other one, if we're going to have the -5s and everything written in like we have right here, then you don't necessarily need to have this negative off to the side or on the very end of the axes as well. I would count having this negative sign written in that you have there, right there, as also indicating the positive and negative directions on the set of axes that you're working with. So if you are setting up a graph for yourself, what you're seeing here, bare bones requirements of what you need. If you at least have this written in for yourself, you are going to be eligible for full points. If any aspects of this are missing, I'm taking points off. If you're missing the labels on the ends, I'm taking points off. If you're missing labeling what direction is positive or negative, taking points off. If you don't have one or both of the axes in the positive and negative directions clearly defined and scaled accordingly, I'm taking points off. If you do not have any aspects of this in here, I'm taking points off, and your future instructors are going to do the exact same thing. But they'll probably take off a lot more than I will. So you need all of this written in before you can do anything else and actually plot any points. Again, the main reason why is, well, let's say I just take off these values that I have here. I take off the axes, the labeling that I have on the end. Well, now suddenly I don't know which axis is positive, which one's negative, which one's X, which one's Y. Because technically speaking, we're going to get kind of weird with this here, I could technically label this to be the positive Y direction and this to be the positive X direction. And then I could label each of these tick marks to go by, let's say I went by 5s. So I went 5, 10, 15, 20, 25. This is a positive 25. Here's a positive 25. I could define this thing any number of ways. And if you don't have your way of setting up your axis clearly labeled and defined in the on the set of axes and all that stuff, I don't know what you are working with. So while we do have some of these universal standards of, yeah, the x-axis is pretty much always going to be the horizontal one. Yeah, the y-axis is pretty much always going to be the vertical one. Make it abundantly clear for yourself. You are going to find later on in this course, and very likely, I think it's in Math 97 we see it more, where you are going to be working with it where it's not the standard x, y, or it all counts by ones. So you need to have all of that written in for yourself, make it clear. I know I'm spending a lot of time talking about this, but it cannot be underestimated or understated with these. So let's get to plotting some of these points now. I'm going to do some of these in different colors. You do not need to follow all of the process that I'm doing. I just want to make it abundantly clear how we're going through and plotting these things. So I'm going to do point A. I'm going to do that in blue so we can track this here. So plotting points, we always start from the origin, right at the very middle of our set of axes. The first value in our ordered pairs, number 2, tells us how far, which direction we are moving along the horizontal axis. So our first number is a positive 2, so I'm moving 2 in the positive direction. So I'm just going to use little tick marks here, little dots. So I go 2 in the positive direction on the x-axis. I'm going to move vertically. Right-hand number, or output value, tells us the direction and the number of places I'm moving vertically. So I have a positive 4, so I'm moving 4 in the positive direction. I'm going to be ending right here. Oops, so I have point A. And I'm done. Looking at point B, I'm going to plot that one in red. So starting from the origin, let's do it with all of them. I'm moving 1 in the negative direction along my horizontal axis. So moving over to here. Now I'm moving 2 in the positive direction along the vertical axis. So I'm moving up 2. Oops. I have B. Plot C with yellow here. Again, starting to see the pattern here. Starting from the origin, I'm moving 3 in the negative direction along the horizontal axis. So 3 to the left. And then I'm moving 5 in the negative direction along the vertical axis. So I'm going down 5. Oops. I have my point C right there. We'll label that. And then we'll use green for our last color here. So I'm going to use point D is going to be in green. So once again, starting from the origin, I am moving 5 in the positive direction along the x-axis. Okay. And then with 0, that tells me I am not going to move up. I am not going to move down in the vertical direction at all. So I'm going to stay right on the x-axis that I have here. And point D is right there. So as I went through this, and I am listing and putting those little dots in there to show we are moving left, right, up, down, anything like that, you guys do not need to have those dotted lines showing up in there on yours. All that I would need to see is there's a point, there's a point, there's a point, there's a point. Okay? Those dotted lines are just to track where we are going, where we're moving as we're going through and learning this process. Again, not required. Just need to make sure we have everything plotted and we're moving left, right, up, down, the number of directions accordingly. So again, make sure you have everything, your positive direction, your negative direction clearly defined, not just for you, but for me and whoever else would be grading this as well. But this is how we would go through and we would be plotting points on any set of axes that we're working with. Okay. So I'm going to jump us back to our notes. We're going to take a look at plotting a graph. So again, those are examples that we just went through right here. So that's where we're getting our numbers from. So plotting a graph. So we've been given a graph, we'll be given an equation of some kind. There's a bunch of different ways that can look. We'll go through some examples of that. So the way we are going to go through and plot a graph. My recommendation when you're doing this, create and label a table of points. For linear equations, we need at least 2 points to plot them. The book and other sources may tell you that you need 3 or 4 or 5 or something like that. We really only need to have 2. But there is nothing wrong with having 3 or 4 or more of them as well, if you would like to have additional points. That's fine. It's perfectly acceptable. When we are doing this, we may choose the independent variables values, meaning the input values, for our ordered pair, and must then calculate the corresponding dependent variables value, the output value. This generally corresponds to the independent variable, or the input, is the x value. And the output variable's value, or the dependent variable, is the y value that we normally have. This is the generality that we go with. Now, I will let you guys know that depending on the problem that you are working with, you can technically choose to have either the x value or the y value at the very beginning when you are trying to find an ordered pair. That being said, here is the big warning. You may not choose both an input and an output value for an ordered pair, as you don't actually know if that chosen point satisfies the equation. Primarily meaning, using the quick example that we have here, here's an equation. If I were to just randomly, arbitrarily choose a point, an x and a y value, I don't actually know if that is going to be on this equation, or going to be on that graph at all. So you can only choose the x value or the y value, and then you would need to go and find the missing one that goes along with that ordered pair. We'll go through a couple examples of this, and I'll show you what I mean by that. But you cannot choose both for each ordered pair. You have to choose one, find the other. A lot of people make that mistake of, I'm going to choose an x value and I'm going to choose a y value that I think goes along with it, and then there's my point. You don't know if it's on this graph and equation that we have. You cannot just guess and randomly choose at everything with that. And again, we'll go through an example with this. We'll use these and a couple others if necessary. Once you have at least 2 points, you plot these points, you calculate it, and connect them in a line. When you're doing this, I would highly recommend you use a ruler or some sort of a straight edge to connect those points together. I believe WAMAP generally sets up pretty nicely for us the option to choose 2 points and then connect them together. So that's what that's going to look like on the program. When you are plotting and making these things on your scratch paper, which is what you should be doing, I would recommend using a ruler or some sort of a straight edge to connect those points together. If you do not have a ruler or a straight edge and you are just going by freehand, just please do not make it something where it's like, okay, I'm going to just quickly put it together. It's not even close to the line. Take some time and take some care and pride in what you are doing and writing out on the paper. So do your best to connect those together for yourself. So we're going to go through this instance where we are asked to graph the equation y equals 3x plus 2. We're going to assume we don't have any of this, and we're going to go through and actually solve and find each of these points as if we didn't have any knowledge of what these were, using what we have here. So we're told to graph the equation, and this is what we are given to start with. So I'll jump us over to our whiteboard, and we'll go through this example. Oops. Why does it always do this to me? There we go. So we're told to graph y equals 3x plus 2. This is all that we'd be starting with on the homework or on the test or anything like that. Now again, to plot a linear equation, which is all the types that we're going to be working with for this chapter, we need to find at least 2 points. If we have 3, if we have 4, if we have 5, if we have 10, whatever, great. We have more than we need, but we need at least 2. If you don't have 2, you can't do anything. You can't plot this thing at all. So again, my recommendation to you guys, set up a table for yourselves. You can do it horizontally, you can do it vertically, it's your call. I'm going to do it vertically because I like to use working math vertically here. I'm going to have, here's my x values, here's my y values. Oops, actually, I'm going to move this down here just a little bit. So a little bit of space here. And again, I need to have 2 points, meaning I need 2 ordered pairs with this. Now, as I put in the directions that we have here, we can choose, and I generally recommend this, choosing an input value, so choosing an x value. Now we can choose any number that we want for our input values. So I am going to choose 1 for my x value. You could choose 2, you could choose -1, you could choose 0 if you wanted to. I'm just arbitrarily choosing 1 because I want to choose 1. Now I need to find what is the corresponding y value that goes along with it. So how do we do that? We're going to have to go through and work this thing out. So if I let x equal 1, then in my equation, I need to plug 1 in for x. And now I'm just solving this thing out. 3 times 1 gives me 3. 3 plus 2 is going to give me 5. So with an input value of 1, I'm getting an output value of 5. I'm just doing this in blue so we know which one we started with, which one we solved for. Okay. Now, let's say instead we chose an input value of, we'll say 0, because we arbitrarily choosing another one. So I'm choosing another input value of 0. Okay? Again, you can choose whatever one you want. Off to the side, I need to solve for that. So if I let x equal 0, what is my y value going to be? Well, I'm going to choose to write that in there. So if I'm letting my x value be 0, come on, pen. There we go. Write that in. This first step here of writing in that input value, a lot of people do not do this step. And a lot of people get incorrect answers because they do not do this step. So write that in for yourself. 3 times 0 is 0. 0 plus 2 is 2. So I just found my y value. So with a starting value, an x value of 0, I found that my y value is 2. And good there. So I now have 2 points. If we want to write these off to the side for ourselves, we can do that. Some people like doing this. You are not required to, but there's nothing wrong with it. So this gives us the pair 1, 5, the ordered pair 1, 5, and the ordered pair 0, 2. Now, we're going to go slightly overboard with this. I'm going to choose another x value just for the sake of showing you guys that you can do this. Let's say we chose, I want to have 3 points. For whatever reason, I like having a positive value, a 0, and a negative value. It's personal preference on that. Again, we only need 2, but there's nothing wrong with having more points to work with. So I'm going to choose an x value of, let's say, -2. So I'm choosing my x value to be -2. There's nothing wrong with having a negative in there. And again, just like we did with our previous ones, Just plugging in -2 in for x. 3 times -2 is -6. -6 plus 2 is -4. So I have a y value of -4. Translates into the point -2, -4. So now, okay, I'm told to graph the point y, or the equation y equals 3x plus 2. And now, looking at this thing, I have 3 points to choose from. I need at least 2. So now I can choose between any 2 of these points that I want. I could plot all 3 of them if I wanted to. But I at least need to choose 2 of them, plot those, and connect them together. So it's your choice on whichever ones you would like to choose. We just need to go through and set up our axes, plot those, and connect them together. So that's what we're going to do. So again, we are going to be graphing this thing, so we need to follow all of the requirements for setting up a graph before we plot and connect any points together. So I'm setting my origin to be right here. So here's my horizontal axes, and here's my vertical ones. You guys will have graph paper, or at least I'm hoping you guys will have graph paper and be able to graph this a bit better than mine is. So I've got my axes. I'm labeling my positive direction, my negative direction. I'm going to label the x and y axes as well. And I'm going to go by ones here. So horizontally, I'm going by ones. Vertically, I'm going by ones. And again, if you have at least this written in for yourself, this is the bare minimum requirements I'm looking for. So if you do this, I'll make this a bit better here. If you at least have this written in, you're fine. Okay. I know some people like to do, and I'll show this as well, just for the sake of showing you guys different ways of setting this up. Some people like doing 1 or 2 points along the way on the axes. So if we're out at 5, maybe they want to put 2 right here. -2, there's a 2, and there's -2. Again, this is an option. You do not need to do this, but some people like having this written in for themselves because it helps keep track of points along the way, which is fine. You're more than welcome to do that. Now, we need to choose 2 of these points that we have up here. I'm going to put these in boxes in here so we don't lose track of them. I need to plot at least 2 of these points. It does not matter which 2 you choose. You just need to pick 2 and plot them. You could plot all 3 if you would like to also. There's nothing wrong with that, but you need at least 2 of them. Okay. For the sake of having it stand out, I'm going to plot these points in red so it stands out a bit more against the stuff that we have on our graph. So I'm going to plot, we'll plot all 3 of these for the sake of additional practice. So the point 1, 5. So from the origin, I'm moving 1 in the positive direction horizontally, and then 5 in the positive direction vertically. So I've got my first point right up here. It's at 1, 5. My next point is at 0, 2. So 0 for our x value, our input value. That means from the origin, I am not moving left or right at all. I'm just staying right there. And then I have a 2 for my output value, which means I'm moving 2 in the positive direction, which means I'm going to have a point right there. My last point that I have is -2, -4. So it means I'm moving 2 in the negative direction horizontally. And then I'm moving 4 in the negative direction vertically. So horizontally and then vertically every time. So our third point right there. And now, so mine's not going to look particularly as good, but you guys, you'll have a ruler. You can connect these points together. So I'm going to try and do this as best I can. We'll do it from here. Okay. So it's not the perfect thing in the world, but Again, you guys get the idea of what we're going with this. So if you guys have a straight edge ruler, I've seen some people use part of like their credit card or something like that, which is pretty nice, to connect those points together. That's all you need to do. Now we have our equation plotted. These are the requirements. This is all that we would need. Now, we can and will have instances where we have, and I'm just kind of straying from the lecture notes that we have. We may have instances where we're told to, okay, so we saw a graph y equals 3x plus 2. We might have something where we're given an equation in the form, maybe it's 2x minus 3y equals 7. And we're told to plot, we're told to plot this equation that we have up here. So it looks fairly different from the one that we just worked with. However, nothing is changing in our process. You are still choosing either an x or a y value, and then finding its corresponding other value. So you choose x, find y. Or you choose y, find x. Either option. The other one that you can do, let's say you have something set up like this, you could rewrite this, because we have the tools for this, you could rewrite this into the form of y equals, and then something written out. You could solve this equation for y, and then find your answer from there, or find your equation from there, and then find your x and y values accordingly. So just because the starting equation might look a bit different than what we went through with our example here, come on, there we go. Just because these things might look different from one another, the process is going to stay the exact same. Our requirements to graph these things is going to stay the exact same. The way that we set up and find our 2 points, at least 2 points that we need, is going to be the exact same. All that's different is that starting equation. It just looks a bit funky from what we're used to seeing. But you solve for it and everything the exact same way. Okay. So I'm going to jump us back to our lecture notes because we have 2 special cases that show up when we're going through and plotting these things. I'll show you guys what those look like as well in graphs. So we have that there. So we have 2 exception cases when we're graphing. These are graphing vertical and horizontal lines. So every horizontal line that we're going to work with is always going to come in the form of y equals just a number. So whenever we are told to graph a horizontal line or graph the horizontal line of blah, 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 whatever it may be, the equation is always, always, always going to be of the form y equals some number. It could be a positive, it could be a negative, it could be 0, it could be a fraction, it could be a decimal, any combination of those. But a horizontal line is always going to be of the form y equals a number. Same thing with a vertical line. It could be a positive, negative, 0, fraction, decimal, whatever. But the only difference is it is going to be of the form x equals a number. So when we are asked to solve or graph the horizontal or vertical line y equals something or x equals something, these 2 cases, we do not actually need to find 2 points for them. We already know what these things are going to look like. We just need to find where am I putting this on my horizontal line or my my x-axis or my y-axis, basically. So we'll go through an example of what this means. I'll just make one up here over on the whiteboard. But these are the 2 forms we're going to have for our horizontal and our vertical axes or lines accordingly. You do not need to do a bunch of additional work with finding points for these, because what's really nice is pretty much all of them are going to have half of their points the exact same. And I'll show you what I mean by that here shortly. So let's jump over and plot these things. plot each equation, I should say. So our first equation is going to be y equals, let's go with y equals 4, because why not? And then for part B, we'll graph x equals -3. Okay. So this is a type of problem it could be. I'm told plot y equals 4 and plot x equals -3. Okay. So I'm going to plot both of these on a single set of axes. Again, I'm going to use blue for my first one. I'll use red for the second one here when we get to that. So again, to plot these things, I need to set up my set of axes. You need to follow these requirements every single time. I'm trying to hit this home as best I can. I know it's annoying that I'm saying it all, but I don't want you guys losing points. And I will absolutely take them off if you aren't following these requirements. So we have our axes set up like this. Positive y, positive x. Okay. So we've got everything set up there for ourselves. We've got our axes set up. We've got them labeled. We've got them scaled. We know which direction is positive or negative on each of them. Now, looking at our first equation that we have, y equals 4, if we know in our heads that is a horizontal line, great. So we know what that thing is going to look like. It's just going to be horizontal. So now I need to determine, okay, where is it going to be horizontal? Is it going to be horizontal way up here? Is it going to be horizontal way down here? Where is it going to be at? And the giveaway with this, we're told y is equal to 4. So let's think on the general shape, as it were, of a horizontal line. Looking at each point on this line, could say, ask ourselves a question of, okay, well, what is the x value? Well, the x value is always changing because it's going to be, it could be here, it could be here, here, and so on and so forth. But what is the y value in these? What's our value that we have on our y-axis? Well, the y value is always 4 because it's a horizontal line. The y value isn't changing. So where do I plot this thing? Well, I find where 4 is on my y-axis, which is right here, and then I build the horizontal line right along there. And there is my horizontal line of y equals 4. I don't necessarily know what the x value is at any point along here, but again, I know the y value is 4 as it's defined in the problem, and that's always going to be the case at any point along that graph. So we're following a very, very similar thinking, but just with our x value now. So again, we're told x is equal to -3. We know that is a vertical line, so following a similar thinking pattern, vertical line, it could be here, it could be here, it could be here. We know that the x value is always going to be -3. The y value could be anything, if we're looking at it in this regard. We're told, okay, so what is the x value always going to be? The x value is always going to be -3. So I need to find where is -3 on my x-axis. That's right here. And then right there is where I'm going to plot my vertical line. Oops, that's part of it. And there we have our vertical line. So when we are asked to do this, we do not need to find two ordered pairs for a horizontal and vertical axis because we know the general shape of them from the beginning. So we just, I think in the in WAMAP, if it's asking you, I think because they have the way they have it set up is you need to click on 2 points to connect 2 lines together. So again, I would do something to the effect of click on a point here and then click on a point that's directly above it, and that will create that line in WAMAP. Similar with the horizontal line, find where that point is on the y-axis and then just find some other arbitrary point that's just off to the side of it, like that. So something like that, that's how I would set up and we would plot a horizontal and vertical lines. So that's what I would be looking for on your scratch work. Again, you wouldn't need to find 2 points. You wouldn't need to make a table for these 2 special instances of graphing. For all other ones, though, you're still going to want to and need to find that table of points. But again, these are the 2 exception ones. This is all you would need to do. So I'm going to jump us back to our lecture notes here. We'll get to the very last bit of stuff that we need to go through. So the last part that we have here is the solution of equation with 2 variables. So a fair amount of the time we could be given some points and we're asked, is this a solution to the equation that we've been starting with? Or is it a solution? Does it satisfy an equation? Things of that nature, some buzzwords for there. So if substituting x and y with a and b in a 2-variable equation for the respective variables produces a true statement, then the ordered pair AB is a solution and satisfies the equation. Some of the terminology that we could see it written in as. So what exactly does that look like? Well, we have an x and y value. We've been given a and b to be 2 numbers. It could be positive, negative, 0, fractions, decimals, any of that. And we're seeing, does this point satisfy the equation? Or is this point a solution to an equation? So our example that we have here, we're asked which of the ordered pairs is a solution to the equation y equals x plus 1. We could also be asked this as which of the ordered pairs satisfies the equation y equals x plus 1. So 2 ways that this could be written. They both mean the exact same thing. So what we have to be given to solve these things, we have to be given an equation. It could look like this. It could look like any other form that it's written in as a linear equation. It could have any other way it is written. It could be y plus x equals 1. It could be 2x minus 3y equals 10. Doesn't matter. We have to be given an equation, and we have to be given at least 1 point. We have 2 that we're working with here, but we're just going to work with them one at a time. So how do we work with this? Okay, so I've been given an equation, I've been given a point. Start off with writing the original equation down, just like we have here, and then substituting in each of the values for their respective variable in the problem. Again, we are assuming, and it's going to be assumed in these instances of these problems on the test and on the homework, first value is an x value, second value is the y value. So I substitute 4 in for x, 4 in for y, and now I'm going to simplify the left side, simplify the right side, and see what the result is. So on the left side, I get 4. On the right side, I get 4 plus 1 is going to give me 5. 4 does not equal 5, which means that this ordered pair is not a solution to this equation. What this looks like graphically is that this point, 4, 4, is not actually on this line if I were to graph this thing. Hence why it is not a solution. So we'd go through this, we'd find 4 equals 5. Well, 4 does not equal 5, not a solution. That's all that we can do. That's all that we'd be solving for. Let's work with the point -1, 0. So again, we're starting with write out the original equation. A lot of people do not do this step. A lot of people just jump to this one or jump to start plugging things in and starting to solve all at once. Do not do that. When people ask me, I don't know what I'm doing wrong here, I always ask them, did you start off by writing the original equation? Did you start off by just substituting the values in first? If they didn't do that, then that's generally where errors show up. So we wrote the original equation. We substitute values in. -1 is our x value, so it substitutes in for x. 0 is our y value, it substitutes in for y. Simplify the left side down, we just get 0. Simplify the right side down, -1 plus 1 is 0. I find 0 equals 0. That is a true statement, which means the point -1, 0 is a solution to this equation. And what that means graphically is if I were to make a graph of this thing, I would find the point -1, 0 to be aligned somewhere along this graph. And that's what the graphical translation of the solution to an equation represents for us. Okay. So again, if you were asked to determine if the ordered pair is a solution to the equation, if the ordered pair satisfies the equation, this is the process we're doing. We're plugging in that value for x, plugging that value in for y, solving each side or simplifying each side of the equation accordingly, and then comparing what we get on both sides. If they are the same, that ordered pair is a solution, or it does satisfy the equation. If they are different from one another, it is not a solution, or you can say it does not satisfy the equation. Two ways of saying the exact same thing, either one works. But again, write out that original equation in your first line. Your second line of work is just substituting in the x and the y values accordingly. And then after that, then you are just simplifying the left side, simplifying the right side. And remember, if you are simplifying, that is using our order of operations, that's using PEMDAS to guide our process for that. So this is everything for our 4.1 and 4.2 material, working with rectangular coordinates, with graphing, with solutions to an equation with two variables. So again, I cannot emphasize this part enough. If you are not doing this with all of your graphing, then this is your warning. If you're not doing this, I will be taking off points on the test. I can promise you that right here, right now. If you do not have this stuff set up for yourself on your graphs, if you just have a horizontal line, a vertical line, and then some sloped line written in there, I'm taking off points. Even if you plot that correctly on WAMAP, if what you have written down for your work is not that, or it doesn't have any of this stuff labeled in it, I'm taking off points. It will go in and I will manually change the grade in WAMAP to have that reflected. Because you absolutely need to have this written in correctly for yourself. Because the points that I might take off, I promise you guys right now, your future instructors on the Math 97 material, your future instructors in pre-calculus, any of the Math 107, 108, whatever classes, if you do not have this written in there, I think there's a fair amount of the instructors who will say they might give you like 1 point or half a point if the actual graph is correct, but they'll take off pretty much all the other points if you do not have this written in. So you absolutely need to have this written in for yourself. I cannot emphasize this enough. It's absolutely critical that you do that. Okay, so this is everything for our 4.1 and 4.2 material. I'll end our recording here and then take any questions that you guys have from there.